So now probably one of two extremely difficult parts of simple harmonic motion is representing it as a second order differential equation. So it looks incredibly disturbing, but if you break it down, it isn't actually all too bad. So we have this general expression, which reads a d2x by dt squared plus mu dx by dt plus omega squared x equals 0. So actually plus omega squared, not minus omega squared, so apologies for that mistake in the first video. So the mu dx by dt part is actually the damping that we're going to consider soon. Whereas something known as a smooth oscillator, so that's from the smooth table sort of approximation that we had at one point, would represent as this, because mu is essentially the way you represent any disturbing forces or frictional forces. And so we can see omega squared x cropping up again, and obviously we can see that a d2x by dt squared equals minus omega squared x, which again shows that these two things are proportional. Now, how do we actually go ahead and solve one of these? Well, in a quick way, there is a very long process on doing it, but we can say that a smooth oscillator has the form d2x by dt squared plus omega squared x is 0. We're just going to a equal 1 here for simplicity. So if we let m equal dx dt, then we can say that a m squared, so there actually should have been an a in here, but solving this will get us that m is plus minus omega, which is a bit weird, but it's essentially, these should actually be complex roots, so I'll actually just resolve this again, because I think there's a mistake here. So it's minus omega squared, and so m squared is plus minus, oh no, m is plus minus square root omega over a. So these should actually be omega over a's and not just omegas. So let me just go ahead and fix this. So these should be, that should be omega over a, should be omega over a. And so the general form just incorporates sines and cosines, again referencing the fact that it's simple harmonic. And so I'll actually just write x is a cos of omega over at plus b sine of omega over at, where capital A and B are constants and little a is the term in front of d2x by dt squared. So this should actually also read that this is omega I, so m should be I, if I remove this. So we're going to just show an example. Now, I'm not going to ask if you want to have a go. If you want to have a go and you know how to do this, then obviously far ahead. But I am just going to go through how to do what might seem initially like a really complicated one, but it will eventually come to fruition about how sort of crank the handle it is.